Happy New Year! You're watching Model Anything.
Hello and welcome back to Model Anything. Today's episode we're looking at a very special piece, a hand-painted blown glass Christmas ornament with kind of a peppermint candy design going on here. At the time of recording this, it's the middle of January, getting close to February actually, so a little bit late for the Christmas scene, but it makes such a nice model that I hate to cancel this or put it off till next Christmas, so we're just going to roll with it. My plan for this episode is just to cover the blown glass portion of this. There is a neat cap to this that gets bent down over the sides of it, and that would be a good exercise of sheet metal, actually, because it's just a real thin plate of brass that's gotten bent down, and it's got some nice indent patterns on it, but I don't want to do that for today. Maybe that could be another video sometime in the future. I just want to work on this because this is enough of a challenge all on its own. And this is really one of those models that you can't just like dive into it and start modeling. It does take some pre-planning, some trial and error. And so what I've concluded is the best way to go about this is to start with surface modeling, to use the surfacing tools to create this, which I don't normally do. Usually when I'm creating a part, I don't start from the surfacing level. Usually those surfacing tools are just handy to go in there and do repairs, or if you need special treatment at different places. But in this case, starting from surfacing seems to be the answer. So here's how I want to do this. This stripe pattern is a little bit tricky because it starts on one side, kind of swoops down, comes up on the side, and continues. So you can't just mirror across a plane on this. It's a continuous pattern, but there's still a shortcut that we can use to create this continuous stripe pattern. And the way to do that I found is to just model one of these stripes. Just pick a stripe from this picture, model one of these stripes, and just do one half of it. So we're actually kind of splitting it right here as far as our model goes. And later we're going to go back and actually do a circular pattern where we'll flip this over to the other side to create that continuous pattern. Now, as far as modeling this part of the stripe, it is a little bit of a trick for a couple of reasons. For one thing, this isn't just a matter of splitting faces to create these stripes. This ornament actually does have physical contours to it for each stripe, so you get sort of this bump along each of these stripes that continues along this face down to the center of this. So it's going to be sort of a two-part process to create these stripes, because we're going to have to create the general shape, like from a flat angle, create the general shape of the stripe, and then go in there later and adapt it so it's actually got this curvature to it. And that's where your surfacing tools really become necessary. So the basic steps that we're going to follow to create this are as follows. Number one is we need to create this wheel shape as kind of a starting point that we can create our surfaces from. So number one, revolve. Of course I picked the dead marker. Number one, we are going to, oh that's better, revolve the wheel shape. And so we'll need to create an axis that this wheel kind of wraps around, and we'll use a style spline to create one side of this wheel and revolve it around. So that'll give us a wheel shape. Number two is we need to define the profile of this stripe. So we'll just pick one of these stripes, and we'll draw out the shape as it looks from the front view of it, and we'll project that stripe onto this wheel shape. So number 2 is create the stripe profile. Create stripe profile. Number 3 is to make some changes to the stripe to have this kind of curvature to it. So at this point we're going to have sort of just a nice flat wrapped stripe, but we actually need to make this sort of a bump. So we'll have to go in here and draw in a arc from which we can fill in a new surface using the edges of that stripe and the arc. So make it bumpy. And step 4, by this point all the hard work is done, hopefully. I will put the caveat in here, anytime you're working with surfacing tools, unexpected stuff can happen, but hopefully by this point the hard work is done, and we can use a circular feature to create the rest of these stripes based on that one stripe that we made. Circular pattern of stripes. Circular pattern of stripes. And once we have one side of the ornament done, it's not going to be a mirror because this is a continuous pattern. It's actually going to be kind of flipping it over this way. So kind of coming straight out from the board, we've got another axis. Sorry for hitting the microphone there. And we're going to flip this ornament over on the other side, create a copy of it, flip it over, and do whatever rotation is necessary to match up both sides of this stripe. So at that point, we'll basically have the ornament done, but it's still just going to be surface bodies. We'll go ahead and, let's see, circular pattern. So number 5 is create other half. Number 6, we'll just make this boss up here. This is just a cylindrical boss that sits on top, so extrude cylinder. Hopefully you can still see that. And finally, number 7, shell out the part. And if we have any faulty faces from the surfacing, then shelling might be problematic, and there will be other things we can do. But hopefully it's going to work. So without further ado, let's get modeling.
Alright, so here we are in SolidWorks. I'm running 2021 on this machine, and let's start a new part. And I'm in inches for units. And to start, I want to get some definition in here for this Christmas ornament. An easy way to do that for kind of complex shapes like this is to use Sketch Picture. You know, from my last video, I'm rather fond of that command. So we want to base the kind of most defined side of this ornament on the front plane. So it's, first all I want to do is just put a circle in here to define for the picture how to scale it to get the diameter right. So I'm going to set a circle to about 3.1 inches. That's all I need for that sketch. And again on the front plane, let's go ahead and bring in that sketch picture. So new sketch on the front plane. Up here in the search command bar, that's how I like to find sketch picture. Just put in sketch picture, there it is. And I want that top view. And now it's just a matter of kind of visually lining up the picture with how big that feature needs to be. And really that's what the scale tool, what it's made to do, is to kind of lay it over a feature and match it up with other things in your model. But it's, for me, it's just as easy just to go in here and kind of visually match it up, and that actually looks pretty good right there. So that's all I need for the sketch picture. And on the right plane, I'm going to put a little bounding box in here. So on the right plane, I just want to set the definition for how tall this needs to be. So all I'm doing from the side here is I want to set the bounds for how thick this ornament is, and again I want to match up the diameter from the side view. So I'll get a corner rectangle, bring it up, and again that diameter is 3.1, and the thickness, I did use calipers for this, the thickness is like 1.875 inches. And I'll make this for construction. I make things for construction a whole lot, so I've actually done a hotkey to K for construction. That way you can just real easily, quickly go in there and make conversions. Hit OK. Okay. And we'll go ahead and put in the side view of that ornament. So on the right plane again, let's do a sketch picture and fetch that side view. And again, it's just a manual process of matching up your picture with your geometry. So it's like, yeah, that's close. And so there we've kind of got a virtual part in there. But that's going to make it easier for us to work with here. So here's where the planning phase comes in of how we need to construct this. So the first thing I'm going to do is just revolve around a wheel shape for the general shape of the model. And I'm going to draw from the front view that curve that makes up the stripe. And by intersecting that sketch with that wheel, we can get an intersection curve that works in 3D, and it's a lot easier than like trying to do a 3D sketch and doing splines in 3D, and yeah, SolidWorks has tools that makes that kind of thing pretty easy. So what we need to do is set up some axes, because there's going to be a couple of different rotations happening, or revolves and circular patterns happening, and so we need to set up some axes. And a real quick and easy way to set up axes is with your default planes. You can just use the intersection of planes to set up an axis. So I know that I need one that kind of jets out towards the screen from a front view. So that would be the intersection of the top plane and the right plane. So I've picked these two planes, and I'm going up to features and reference geometry. Oh, I'm still on a sketch, so I need to get out of the sketch. So top plane, right plane, reference geometry, axis, and it sees the intersection of those two planes, so just hit OK. So there's our first axis, and later on I'm actually going to need an axis that goes from left to right. So it would be the intersection of the top plane and the front plane. Yeah, top plane, front plane will give us the other axis that we'll need. So I've pre-selected those. Go to reference geometry, axis, and we can just hide that one for now, but we'll need that later. So let's just clean up the tree a little bit. This is the first sketch was just circle definition or diameter definition. If I can spell, yes, I can spell real good. Second sketch is the front picture. Sketch 3 was the side picture. Sketch 4. Oh, actually, this is my bounding box, side bounding. And sketch 4 is the side picture. Okay, so we've got some infrastructure in place. Now we actually get to create something semi-physical here. So we need to create this wheel shape, and this is a really good place to use the style spline. I don't use it very often when I'm using splines. It's usually a lot more freeform, loosely defined. But in this case, I actually want symmetry, and the style spline is good for that. So I'm going to create a sketch on the right plane to get a kind of a cross section of this wheel shape that we're going to be starting with. So let's get the style spline, which is a drop down from the spline tool here. And what this does is it uses straight lines as your kind of spline handles, and they're lines that are easily dimensioned, easily given relations to. So to create this, I'm going to go vertical and horizontal, vertical again. Let's make this vertical. And just match that up to the diameter. I know the real model is a little flatter on the sides and on the top, but this is a little easier to work with, easier to define it. So I'm just going to roll with the style spline on this one. And again, need to make that vertical. And make this one horizontal. And we do want to make sure that this does precisely match the diameter that we set, so you can just take the spline, select that bounding box, and use tangent. And so you see the spline is black now, so it's fully defined. And since we use vertical relations, we know that it's got a nice tangency right here at your endpoints. And we don't actually have to close this off because this is going to be a surface body. We're not starting with solid geometry, we're just giving it surfaces. So we're going to finish the sketch. And let's go ahead and revolve that shape that we just created. So we're going to use the Surfaces tab. And if your Surfaces tab isn't up there, you can just right-click any tabs that you do have, and on this tabs drop-down, you'll see available tabs that you can make active, and Surfaces is on there. So just go in there and make sure Surfaces are there. And the surfacing tools, if you haven't played with surfacing, there's a whole lot of analogy between the surfacing tools and the physical tools. Of course, there are very special commands in here for surfaces, but like revolve, sweep, loft, extrude, they're very similar to your solid modeling commands. So creating a revolved surface is really just the same as it would be for creating a revolved solid. So the axis of revolution is going to be that first axis that we created, and it's going to make this wheel shape. And 360 degrees is fine. So now what we've got is kind of a hollow wheel, or an M&M, or however you want to look at this thing. But it's hiding some of the artwork that we need, so for right now I'm just going to hide that body so we can still see our sketch. But just remembering we have that wheel shape out there. So now in the front plane we can go ahead and create a sketch that's going to define one of these stripes. Okay, now there is a little bit of a perspective issue here with this image where the center of the pattern doesn't lie directly on the center of our circle, but for the sake of a good model we're just going to assume that it does. So we'll match it up close, but it's not going to line up exactly with the picture. So what we need to do now is pick one stripe that we want to define, and really all we need is one side of one stripe, because we're making the assumption that each of these stripes are equally spaced, that the white stripes are the same width as the red stripes. And so once we've created the side of one stripe, the hard part's over. All we have to do is just use a circular pattern to create the other side of the stripe. So this is a case where we really do want to have a free-form spline. So I'm just going to go up here to the spline command and just need to pick one stripe that looks like it's pretty well defined and use it to trace. So going from the center of the circle, I'm going to take out a spline and go to what looks like the edge of the stripe here, and wake up your spline handles and just drag this to kind of match the contour of the stripe. And one thing that is a little bit tricky about this is the end of the spline actually does need to go up at a particular angle for it to match up when you kind of mirror over the pattern on the other side. It's not really a mirror. When you flip it over on the other side, you have to make sure that there's not going to be any strange, like, jagged edge on the side when those two match up. And what I've found is that the correct angle is at like a 90-degree from a tangent line where that meets the circle. So what I'm talking about, you create a line at the end point of this spline, make a tangent to this circle, and you just make this tangent to that line. So it actually creates a 90-degree there at the meeting of those two entities. So tangent. We'll bring this shape back down. And there we go. So that is what's going to define all the rest of these stripes and every side of every stripe. Next, what I want to do is go ahead and create a circular sketch pattern of that one stripe. And all we're wanting to do is just create one stripe. So we just need, say, two entities. And there are 18 stripes on this ornament. So 360 degrees divided by 18 is 20 degrees. And flip the direction. That's okay. And so now what we've got are these two sketch entities that define one stripe. And so that's all we need for the sketch. And now we're going to get into the fun surfacing part. So just to make things easier to see, I'm going to hide these pictures real quick. So hide the side picture, hide the front picture, just to see what we've got. So we have this wheel shape that we created, and we've got this stripe. Just these two lines that we created. And so let's go to surfaces, and we're going to extrude out these lines that we created and make sure that they go beyond the width of this wheel. So we'll just make it like 3 inches mid-plane. And so that pretty clearly cuts past the edges of this wheel. And we'll say OK. And this isn't actually the exact shape that we want for the stripe. It's good on one side, but you notice that it goes back down on the other side instead of continuing up and creating the pattern that we're going to want. So all we're going to do is just create one side of this stripe. And so I want to trim away the back half of that wheel. And we can do that with the trim surface command, which is how you trim surfaces when you're working with surface bodies. So using the front plane, we're going to go trim surface, standard trim using the front plane, and we're going to say remove sections. We want to get rid of that back half of the wheel. And there we go. And now we just want to trim out this kind of a slice of a stripe that we could get from the intersection of these two surface bodies. So we'll go trim surface. The trim tool is this body, these two lines that we just created, splines that we just created. And we're going to remove that much and say OK. And we're going to hide our trim tool we just had. Believe it or not, the hard part's done. So we're not going to keep this body as the finished product, but this does give us a couple of the lines that we're going to need to create the stripe the way that we want it, because the thing we want to remember is that we have this curved contour to each of those stripes. They're not just flat against that wheel shape, they actually have like a raised surface to each stripe. So to create that, we're going to use these top and bottom surfaces from that stripe we created, but we also need to create another line that's going to give a lofted surface something to work with to give you some raised curvature. So on the front plane, let's go ahead and put in an arc that we'll just say it has a raised amount of, we'll say, 25 thousandths. Not much, doesn't need much. And we want to make sure that this ends where it needs to, so we'll go, that's coincident to that corner, this is coincident to that corner. Finish the sketch, and now we just want to convert the edges of this stripe, so we'll go to a 3D sketch and use the Convert Entities tool to get these two edges. And we'll say OK. And now we can hide this surface, and we're going to create a new surface based off of these three sketches, or these three lines that we have hanging out in space. So to do that, I want to use a Lofted Surface. And we created both of these curves in the same 3D sketch, so we're going to have to use the Selection Manager just to pick one at a time. So Selection Manager, pick that. And then the Selection Manager, that's with a right click, pick that. And then for a guide curve, let's use that gentle arc that we had up there. So, okay. Here's where everything kind of comes together. So we have one stripe, and since we used a circular pattern to go from one edge to the other edge, we can assume, hopefully, that everything's going to match up when we just do a circular pattern around 360 degrees with 18 stripes. So we'll do, from features, we'll do a circular pattern and choose bodies, because these surfaces, even though they look like faces, they're considered bodies. They're surface bodies. So we're going to go around that axis we created in the beginning. We need 18 of these guys. And when we created the width of that stripe, we set it to 20 degrees. So these should match up nicely, since we have 18 times 20 degrees is 360 degrees. And so now we've got these very nice surfaces. And if we want, we can go ahead and try to flip this across that other axis that we created to make the other half of this ornament. So let's hide that first axis and show the second axis that we created. And I'm going to go ahead and knit these surfaces together. Instead of flipping 18 surfaces across the other side, I just want to flip one surface. So let's go ahead and join these surfaces together using the knit surface command. We'll say OK. So now it's just one surface body that makes up that front half. And now let's use another circular pattern. And again, we have to use a circular pattern to create that continuous curve shape instead of just mirroring, because otherwise the stripe would come up and then just go back down the way that it came, which isn't what we see in the ornament again, where it's kind of this continuous swoop that goes up and over to the other side. So we're going to pick this body, and we're going to use, wow, that'd be interesting. You know what, I'm just curious. I want to see what this looks like. Wow, that's interesting. But it's not what we want. Not what we want. So we just need one of these. And we'll say OK. Since everything is kind of symmetric, what we can do is just use move copy bodies to get things to line up. So we'll go with a move copy body. Let's match up this vertex with this vertex, hit add, and come over here, just picking vertexes at random, this vertex with this vertex, and now everything should line up just perfectly. So there we go. Again, knit these together, go into the surface tab, go knit surface, create solid, and we can hide our construction axis. And the only thing left is we need to create this boss coming off the top and then hollow it out. So from the front plane, actually from the top plane, excuse me, the diameter of that boss is 0.5. And it comes up about 0.5 above this diameter, so we'll say 3.1 divided by 2 is 1.55, 1.55 plus 0.5 is 2.05. Okay. And from there we can go ahead and shell this. So we'll go to the features and shell it out and give it a thickness of 25 thou. Pick this top face as a face that's going to be removed and say OK. And there we go. With that, this ornament is basically done, so I'll just apply some appearances to it. We'll give it a primary appearance of candy apple red, so car, candy apple red, and for the white stripes, we'll just give it a high gloss white. So we'll say the other side. Then context toolbar comes up, appearances, the faces are going to be, say, white. There we go. If you want, you could go in here with the section view, kind of look at it, see how everything looks. See how the curvature looks on the inside of that. And there we have it. With that, we have a finished model.
In summary, we did a surface revolve of the ornament's general shape using a style spline. We traced one stripe from our sketch picture. We created a trim tool by using Extruded Surface. We cut out the stripes so we could convert the edges into a 3D sketch. We used the 3D sketch and a 3-point arc to define a lofted surface. We used a circular pattern to complete one half of the ornament. We used another circular pattern to make the other half. We extruded a boss. And we shelled out the part. And that's a model.